Okay, so just waiting for this one. Let me add someone. Yeah. So I'm creating one package here. Dot needs dot. Oops. So today we'll see oops concept. Okay. So oops concept, right? So in oops we have different topic. By one we'll see each of them. So total we have 6 topics, that is main. So like main objective of object oriented programming is to implement real world existing thing. Okay, so in this we have 6 topic. One is object, second one is class, third one is inheritance, fourth one is polymorphism, then abstraction, then encapsulation. So one by one we'll see each of them. Okay, so first we'll see object. Let me open paint first. Right. Let me clear this box. Okay, text box. So oops in Java. Whose full form? Object oriented programming. Okay, so this one is our object oriented programming concept. Let me add underline here. Yes. So in oops we have. Oh, wait. Okay, let me uncheck. First one is object. Then we have class. Then we have polymorphism. Okay. Fourth one is encapsulation. Fifth one is interface. And sixth one is abstraction. So one by one we'll see what is object, what is class, what is polymorphism. Like you are not aware of these 4, but you are aware of object, you are aware of class, what is object, what is class. So when we have to create object and when we are creating class, so if you want to write any program in Java, what you have to do, you have to create class first, then inside that class you'll write your logic. So that is your class. And when it comes to object is what? Object is the when we need object, when you have non-static data. To access non-static data, either it is method or variable or anything, you have to create object of this class. Okay, so we'll see some theoretical part of this object one and this class one. Okay, so first is object. Mm, so what is object? So object have some state and some behavior, that is called object. It means when when we have, for example, we have public class example. Okay, so when we are creating any class, inside that class, if we have declared some variable, for example int num equal to 10, okay, and we have declared some method also, void, it will return nothing, m1, and when we'll call this method, it will do what? It will just print one sysout statement. Sysout statement abcd is something. Okay, so we have one class. Inside that class we have declared this num variable. We have created this m1 method. Okay, so when we are creating any class and to access these non-static data, what we'll do, we are creating object of this class, right? So this class with this example class, this one is one class, right? How will create object? Example, your object name something like ex equal to new example. So this way we are creating object of any class, right? So when you are creating object, you can create multiple object of the same class, right? Like for example like this, same example class, you can create multiple object, but object name should be unique. So if you have created two object of this example class, it means both this ex and this ex. Let's see here. So I have created this oops concept here, right? I have declared one num variable here, num equal to 10. I have created one method void m1. Okay, this inside that I have added one sysout statement abcd, the same program I have written over there, right? Okay, so this one is our class. Inside the class we have created one variable and one method. So to access these non-static data, what we'll do, we'll create object this class, simple. So oops equal to new this one. Okay, so we have created object. So inside this object, if you want to access this m1, we can access it because we have created object of this one. If you want to access this num, we can access it, right? So what, when we are creating objects, so we are giving some name, right? So this one is object name. So you can create multiple object of same class. For example, I have created one more class, but see, I am writing same name that I have written over there just above line number 12. Line number 12 I have given oops. Line number 13 I am again writing that oops name. It is giving error. Why? It is saying duplicate local variable oops, because that oops variable already exists in with line number 12. I'm again giving that same name on line number 13. So that's why it is saying, it is duplicate. So we'll do what? We'll do oops 1, oops 2, right? So when we'll come to object, right? When we'll come to objects, they have their state, okay? They have their behavior, okay? They have their identity. Now we'll see what is this state, what is this behavior, what is this identity. State means when you are creating any variable, when you are creating any primitive data type variable here, primitive or non-primitive, anything. So this one is what? This one is your state. Okay, you are creating some variable, and inside that variable you are initializing some value into that. So when we'll come to the object part, we have three concept in object. One is state, other one is behavior, last one is identity. Okay, so this one is what? This one is state. When you are creating any variable, that came under state part. Okay, and next we have behavior. This behavior. Okay, so this oops concept, inside this oops concept we have different types of behavior. Like we have this object, we have this class, we have this polymorphism, we have this encapsulation, interface, and abstraction. I'm giving this example here. So like let me create let me do one thing. Yeah, let me create one class here, different class, calc. calc is nothing, calc is calculator. Okay, so I have declared one variable int sum equal to 10. Okay, so inside the sum variable we have this 10 value. So this one is what? State. When we'll come to object part, so this one is the state of the object. If you have declared 100 variable inside this calc class, that 100 variable is what? State of the object. Okay, and next we have some method. Okay, so this one is what? This one is calculator. This one is calculator class, just assume. Okay, so inside calculator we have different types of functionality, or you can say we have different types of behavior. This behavior, what type of behavior? We have add functionality, right? We have subtract functionality, right? We have multiply functionality. So this one is what? This one is behavior of this class. Okay, these all three. These all three are behavior. When you'll use this add method, it will do what? It will sum your value. It will add your value. Add your value. When you'll use this add function, it will do what? It will add two number. When you have this subtract, right? So what this subtract will do? It will subtract two number. What is this multiply? When we'll use this multiply, it will multiply two number. Whatever number you are passing, if you're using two number, three number, four number, I'm just giving two number example. If we have two number, right? So inside this method we have int a equal to 10, or I'm creating, see, I'm creating int a equal to 10, int b equal to 5. Okay, so here I'm doing what? Here I'm adding this sysout statement and a plus b. Okay, this add method will do what? Add method will add these two number. Okay, same for subtraction. So a minus b. Okay, same here, a into b. Okay, so this one is our calculator class. Just assume this calculator is not a class. This one is your calculator, whole calculator. This one, calc, calculator. Okay, so we have this calculator. Just assume this one is your calculator. So if you want to add two number, this 10 plus 5. So just assume 10 plus 5. So when we have written here 10 plus 5 and we'll click to equal to, they have added those two number, right? This add method will do that same process. So internally inside this calculator, they have written these type of program. They have created these type of method. When we'll click to plus sign, they will call this add method and they will add whatever number you have provided to that calculator user input part here. Got it? When you are subtracting something, so inside that calculator, they have written these type of program. Whatever number you have entered into that, they will subtract those two number. Same for multiply and same for other user input, like we have divide, we have this x square, we have this 1 by x, right? So this one is standard calculator. And wait, we have different types of calculator as well. We have scientific, graphic, programmer. These type of calculator we have, right? So they have created these type of program. They have created this add method inside that calculator, this subtract, this multiply. So that way these program works. Okay, so these method, what are these methods? These are the behavior of this class. Okay, these are the state of this class, these are the behavior of this class. Behavior means functionality. So in just assume this one is your calculator, right? Add is what? Add is functionality of calculator, right? Subtract is functionality of that calculator. So in calculator, we have different functionality. We have addition functionality, we have subtraction functionality, we have multiplication functionality, we have divisor, and many type of functionality inside that calculator. So the same way that I have written that program here, they have also written these type of functionality, these type of behavior, or you can say they have created these type of methods, or they have created these type of functions. All are same. Function or method, or you can say behavior, or you can say functionality, all are same. When you are creating function, it means you are creating some behavior. Function and method is same. Okay, this add is, you can say function, add is method. Behavior means what? Inside this add method you have written some functionality, you have written some implementation, right? So this one is your add method. When we'll call this add method, it will do what? It will add these two number, right? So let me, so these are non-static method, right? So how to access non-static method? First we have to create object. So calc c equal to new calc. So this way, oh sorry, uh, this way we can create object. Okay, and how to call any method? So first we have to call this add, like we want to add these two number, these a plus b. Okay, so I'm calling c dot add, then c dot subtract. Wait, or not sum, subtract. Okay, then c dot multiply. Okay, when I'll run this program, you see we got a plus b 15, we got a minus b 5, and we got a into b 50, multiplication, right? The same way when we have added here 10 plus 5 15, right? The same way they have created some behavior inside whatever, like they have written some program for this calculator, right? That's why I'm able to access this calculator application in my Windows operating system, right? The same way they have written those program, those add functionality, those subtract functionality, those multiply functionality, right? Any doubt in this? Hello.
No.
Okay,
No.
so in object, total we have 3 point. One is state. So state means, or let me categorize state arrow variable. Okay, so when you have created any variable, this one is your state part. Behavior. What is this behavior? Behavior is this one. When you are creating any function or method, it means you are creating some behavior, you are creating some functionality. Got it? Next we have identity. Now what is this identity? Okay. Unique object. As I said, we can create multiple object of same class. See here, I have created object of this calculator class, right? We can create calculator class object multiple times, right? But if we'll give that same name, same object name to that new object, it will do what? It will give error. Why? Because they said here like c variable already exists here, right? If I'll hover to this c, see here it is saying duplicate local variable c. Why duplicate? Because we have already created c variable, like c object, calculator object with c name on line number 23. So if you want to create again calculator class object, so we have to give unique object name. But it, if we'll give c1 here, it will work because this c and this c1 are unique. Got it? So for this this one is what? Identity. I'm creating one class again for more clarity. So I'm creating one student class. Okay. So for example, a student is inside a student. We have int age. Age equal to 10. So I have declared some student age is 10. They have their name, right? So string name equal to my name, let's say. Okay. So I have my age, I have my name. Got it? Now I am creating a student class object here. A student s equal to new student, right? So as I said, we can create multiple object of the same class. So when we'll come to the real entity, real world entity, right? So this student, there are n number of students in this world, right? But they have this feature. They have their age, right? They have their name. So what is this name? There is some unique name for each. Like in this meeting, we have Asutosh, we have Prince, we have Anup, we have Suprita, we have Rakhi, we have Surve, we have Lakshmi, right? So we have their different name. So when we are creating any class object, we have to provide unique name. That one is nothing, that one is identity. So this one is for which one? Amish one. This one is my age. This one is my name. So I will give this object name as Amish. Okay. Now I am doing again. Let me copy and paste. I am creating this object for Anup. Okay. Anup also have that same age. They have some age, right? Not this 10 one, but they have some different age. But they have this age, right? They have this name. Okay. So this one is Amish object. This one is Anup object. So this object name is identifying that this is Amish. So this one is identity of object. So when you are creating any object, you have to give unique name, right? So our name, like my name is unique, Amish, right? Anup name is unique. Rakhi name is unique. Suprita name is unique. Prince name is unique here. So that one is nothing. That one is your identity. So this one is object identity. When you are creating any object, you have to give unique object name. So that will specify, okay, this one is this one is Amish. This one is Anup. Got it? So any doubt on these 3 points? State, behavior, identity. So if you'll understand these three topics, na, there is no doubt in this object one. So object is the combination of state, behavior, and identity. Got it? Any doubt?
No.
No,
Okay, good. So wait, red. This one is also red bold. Uniquely identify, for uniquely identification. Okay. Identification. It. So we have written their program as well. So this one is our object. So inside concept is same, like whatever we have discussed earlier, right? We have discussed static part, non-static part. How can we access static data? How can we access non-static data, right? So let me copy and paste that program as well. This one. So this one is object. So in object we have covered this state, behavior, identity, right? So again I'm explaining, this one is your variable. So inside this calculator class, calc class, if we have created any variable, it came under which part? State part. So this is the state of the object. Okay, when we are creating any methods, so that is specifying, it is behavior or functionality of that class, right? So that is your behavior. Third one is identity. We can create multiple object of same class, right? So this is our program. Where is that? Yeah, here. So I have created Amish object here. I have created Anup object here, right? So we cannot give same object name to that class, right? If you are creating multiple object of the same class, we cannot give same name. Okay, so this one is unique. Object name should unique when you are creating multiple class of multiple object of the same class. Okay, now we'll move to the next topic. That one is class. Okay. Oh, came on here. Okay. Wait. Control Z. A 18 12. Why they copy? Wait. Copy. Pasting again. Control A is fine. Why it's yeah. Okay, so we have added program for object one. Now we'll see this class here, right? Let me scroll down. Let me pick my one call. Just wait. Yeah, sorry. So now we'll see class. So let me create first this box class. Yeah, black, bold, and 18. Okay, class. What is class? So when we want to write any program in Java, what we'll do? We have to create class. Inside that class, we'll write any program. Okay, so inside this class, if we can create any field, like any we can create any type of variable, right? We can create different types of methods. We can create constructor. We can create block, right? So that type of uh, uh, topic we'll discuss in this class one. So we have already discussed variable concept, we have discussed method, right? So and we have discussed the constructor one as well. Okay, so let me give one. So a class is a group of objects. We have discussed just before this object, right? So we can create multiple object of the same class. So a class is a group of object. So as I have created a student class, right? So a student s1 equal to new student, right? Same, we can create multiple student, right? In this real world, there are n number of student in this world, right? So that's why I'm creating different object of this same student, right? S4, S5. Okay, so a class is a group of objects. So group of object means S1 object, S2 object, S3 object, S4 object, and S5 object up to n. Not like we have only 5. To n, we can create n number of objects with this same class. And when we'll come to the real world entity, like whatever we are covering in this Java, right? Everything is in real world entity. It is existing. So this a student is real in this world, right? Inside this a student will create some methods. So for a student, they have some functionality, right? They can read, they can perform any like they can dance, like these type of functionality, these type of behavior inside that, right? And we have seen that calculator program as well. Inside this calculator we have different types of functionality. We have addition, we have subtraction, we have multiplication, we have this cross section, we have this C. When we click to this C, it will do some task, right? The same way, when we are creating any class, we'll write these type of functionality, these type of behavior into that. So how to create these type of behavior, these type of logic into that? With the help of methods, with the help of static non-static block, with the help of field, right? So let me come to the class point now. So a class is a group of objects which have some common properties. As I have created multiple object of this same student, so each student has some common property, like class name, roll number, their name, email ID as well, subject, like these are common part. So that's why which has some common properties. Got it? So this is the class. So inside that class, what we can do, we can write we can write our logic. So for example, if we have any calculator feature, like if we have this calculator, right? If we have this calculator, so inside this calculator we have different functionality. So to achieve that functionality, what we'll do, every time I have to click to it. So inside this calculator we have different types of functionality. So how to create that functionality? So we'll create some variable, or you can say we'll create some field, right? And we can create some methods. Okay, so these all variable like static non-static both. Methods for same, static non-static both. Blocks as well, right? Constructor as well. I think I haven't discussed this constructor part, right? Okay, we will cover it, no problem. And we can create nested class as well, right? Inside class we can create one more class, so that is our nested class. So when we want to add any logic, right, with the help of these variable, methods, block, constructor, nested class, we can write our logic inside that class, right? So you have already seen program like how to create class. So when we are creating any class, so we have to use this class keyword before our class name. And this public is what? This public means we have already discussed that access modifier part. So we have different types of access modifier: public, private, protected, and default. So I'm giving here public here. It means we can access this calculator class from anywhere in this Java training project. So we have different package, right? We have this package, modifiers package, oops package, com.image.program, com.image.statement, stmt, right? So we can access this calculator class from anywhere in this package, from different package as well. So this one is public. So we have protected, we have default, we have private as well. So we different access modifier is like used for different purpose. Okay. So if you are creating any class, it is mandatory that in that file, like you have created this student, sorry, you have created this calc.java file, right? So it is mandatory that inside that Java file, you can create multiple class, but it should be like if you have created total 5 class, it is mandatory there is only one class that contain this public access modifier before this class. So you cannot add multiple public classes inside single Java file. Okay, so I have created this calc class, right? You can create multiple class inside that. So just see here, calc, oh, sorry, calc class and share. Oh, control y, yeah, calc class and share, right? So here I have created one another class, calc2, right? So we can create multiple class inside single Java file, but whatever class, so this calc class is public here. So you have to give that file name with this class, this calc class. So we have created this calc.java file, and if we'll remove this public here, and if we'll write public to this class, okay, see, it is giving error here. The public type calc2 must be defined in its own file, right? So we have created this calc.java file. So it is mandatory that you have to add that public access modifier into that calc class. So this calc, it will attached. So you have to add this sorry, public access modifier before this calc class. Got it? So we can create multiple classes inside single Java file. As you so see, here I've created calc class, then again I have one more calc2 class. Got it? So with the help of these point variable, methods, blocks, constructor and nested class, we can create different types of logic, right? As we have this addition functionality, as we have this subtract functionality, we have this multiply functionality, right? If your object concept is cleared, there is no like then class will clear as well. Like top that point is same, the same method one, the same variable one, same non-static, same non-static, static and other thing, right? So with the help of these point, we can add our logic into in class. All right. So let me copy this one. Copy what we have, that same program, right? Or let me create the student one. So integer age name. Let me copy. Yeah, age. No, it's not clicking here. Yeah. Done. Got it. So we have covered object class, and now we'll cover which one. Now we have polymorphism. Okay. Polymorphism. Now we'll see what is polymorphism. So by their name, polymorphism. Okay. It is specifying something. Now let me write that one. Oh, right. Yeah. So now we'll discuss polymorphism. Black, bold. Let me drag. Yeah. So what is polymorphism? So by this word poly and morphism, it is specifying something, right? Poly means many, morphism means forms, means many forms. So the meaning of this polyform is many forms. So you can create many forms with the help of this polymorphism concept. All right. So now now inside this polymorphism, we have some category. Okay, so by method overloading and method overriding, we are achieving this polymorphism part, right? So with the help of these two, method overloading and method overriding, we can achieve this polymorphism concept. For example, if we have different methods, I'm taking that same calculator example, right? So in this calculator, let me remove some all. Yeah, so now here I want to add two number, right? 8 plus 5 equal to 13. So I have added here two number, right? We can add more than two number, right? 8 plus 6 plus 9. So here we have added three number. 8 plus 5, 8 plus what? 8 plus 6 plus 9, right? Functionality is same, right? But first time I have added two number. Second time I have added three number, right? So let me write their program. New class polymorphism. Yeah, it is polymorphism. Yes. So this one is our polymorphism. So just assume this one is your calculator class. Okay. So inside this calculator, let me declare int a equal to 10, int a sorry, int b equal to 5, and int c equal to 3. So I have created these three variable inside this polymorphism class. Okay. Now I'm doing what? I'm creating addition functionality here. Addition functionality that we have seen in this calculator, right? So we have added, first time we have added two number, means a plus b. Then we have added a plus b plus c, right? So I'm creating some method here. So this method will do what? This method will add two number and return that number. Or I'm just creating that void type. After this, we'll discuss the different return type as well. So void add one. So this one is our add one method. Add one what will do what? Or I can, so see, I am removing this one. Okay, so void add one. So inside this method we can pass some value in parameter, or you can say argument, we can pass some value. So inside this parenthesis, like when we have discussed method topic, right, we have seen like we can pass some value into that, right? So here I am passing integer type of value, right? One is a, another one is b. Both a and b type is what? Integer. So when we'll call this add one method, what we have to do? We have to pass two arguments. See here, integer a. After that I have given one comma, then integer b. So we have to pass one integer here, second integer here, right? Then inside this method, now we'll use those two A and B. So what it will do, let me just we have to add, right? We have to add those two numbers, so A plus B. So when we'll call this add one method and when we'll pass these two value in argument, it will do what? It will add those two number. Got it? It will add and they will print it. The same way, void add 2. Oh no, sorry, void add 1. Or let me remove this one. Just add, okay. So here I'm adding integer a comma integer b comma integer c. Okay, see here, method name is same here, but functionality is different. Why? This method will add two number. Okay, but when we'll come to this one, it will do what? It will do a plus b plus c. In argument we have to pass total 3 value. So this one is for add 3 number. Sorry, number. Okay, so when we'll call this one upper one add, they will do what? They will add 2 number. They will add, but below one they will add 3 number. See here, functionality is same. Means these two methods both we can use for adding some number. Functionality is what? Addition. These two methods we can use for addition, but this one is for what? Adding 2 number. This one is for what? Adding 3 number. Now when we'll come to this part, see here, many forms. It means addition contain many forms, right? 2 argument, 3 argument. Got it? So polymorphism is many forms. We have addition. Addition functionality or addition form in, I have just written two ways here, right? We can add multiple argument as well. So for addition, we have these two methods. Now, any doubt in this polymorphism? What is polymorphism? What is this many forms? So many forms means what? For same functionality, we have different forms, right? So for the same addition functionality, we have this form. So it takes only 2 argument. It takes 3 argument. So if we want to add 3 number, we have to use this one. If we want to add 2 number, we have to add this, which one? This one. So that is nothing, that is polymorphism. Same functionality contain different form. Got it? Add method is same here. See here, that add method is same, but this add method functionality is different. Like functionality is same, but they are adding 2 number, they are adding 3 number. Functionality is what? Addition. Now any doubt on this polymorphism? What is polymorphism? How can we use polymorphism? Or let me show you one thing. So here we have just created these two methods, right? Now how to use that method? So this one is non-static method. So we'll create object equal to new this one obj. So we have created object of our class. Now how to call add? So we have created add method, right? So obj dot add. So now here I am passing 10 and then I am passing 20. Got it? Now obj dot add. Now I am here passing 10, 20 and 30. So if you see here, first method will do what? Add two number. Below one will do what? Add 3 number. Functionality is same. What? Addition. Right? If we'll run this program, see, we got 10 plus 20, 30 here, and 10 plus 20 plus 30, 60 here. Now when I'll open this calculator, right? When I'll click to 10 plus 20 equal to, they have returned 30 here. So they will call this first method obj.add, and that contain only 2 argument. So they will use this one. And when we'll enter 3 number here, for example, 10 plus 20 plus 30, we got 60 here, right? This 60. So we have to pass 3 argument inside that. Then we'll get the output. So see, functionality is here. Functionality is same here. Both add method is doing that same functionality. They are adding number, but here they are adding 2 number. Here they are adding 3 number. So same addition functionality has different section here. So that is nothing, that is your polymorphism. Same functionality, different forms. One will do what? One will add 2 number, other one will add 3 number, 4, 5, 6, and so on. Any doubt on this polymorphism now?
No, sir.
Okay. So now inside this polymorphism, we have method overloading and we have method overriding, right? So what is this method overloading? What is this overriding? Right? So by that word overloading and overriding, it is specifying something. Like overriding will do what? Like if we have int val equal to 10, right? Now I am doing what? I am just replacing that val with 20. So now this 10 value override with which one? 21. Got it? So this one is what? Overriding. So here we have override the variables value. I have replaced 10 with 20. So 10 override with 20, right? When we'll come to the method overriding. So if we have add method, right? But this add method, where is that add method? In parent class, and we have one child class, they also contain this add method, right? So when we'll call add method, child will do what? Child will replace this parent add with child add. So we have one topic, right? Inheritance. Wait, let me click to this one. Oh, yeah. So we have this inheritance. Where is that? Yeah, I haven't written inheritance here. Oh, sorry. With the place of inheritance, I have written interface here, right? So this is inheritance. Let me erase this one. So inheritance. Inheritance is what? If you have two class, right? Let me create. So first class is parent, right? And I'm creating one class child here. child. Okay. So we have created these two class, parent and child. All right. Parent, I have declared some value. Int val equal to 100. Or I have created some method void m1 here. this out. This is M1 parent. Got it? So these two field, the one val field, one M1 method we have created in parent class. So if we want to use these two method in our class, in this child class, or I've just given this child name here, parent name here for that relation, right? So if you have any class, not with this parent name, any name, and you have one more class with any name, you want to use these property, this first class property in the second one, right? So you can use that field or method in different class. So as we have discussed earlier, if we have two class and we want to use first class value or method in different class, what we'll do, we have to create object, and after that we'll do what, we'll access those methods, right? So when with the help of inheritance, you can do what, you can extend, these value, these property in your class. What you have to do, you have to write this extend keyword, extends parent. Got it? So now you have, now in this, now child contain all the property of this parent class, right? So when we have used this extends keyword, it means they have extended whatever present in this parent class. All right? So tomorrow we'll discuss this inheritance one, how to extend or inherit parent property into child one, and then we'll discuss this one, method overriding and overloading without inheritance, with the help of inheritance, both. Got it? So today we have covered OOPS concept. In his OOPS concept, we have covered object, class, and we are now discussing the polymorphism. Polymorphism, we have to cover method overloading and method overriding. So tomorrow we'll continue with the same. Okay. Thank you for joining today. Yeah.
Okay, thank you.
Thank you.